Hello fellow coders. Today we're going to build a neat little tool using Python and Tkinter. This tool, called the Unit Conversion Tool, lets you convert between different units of length, weight, and temperature. Now let's get started and examine how this program works. First, we import two modules, Tkinter and TTK from Tkinter. Tkinter is Python's standard GUI, graphical user interface, package, and we're using it to build our application interface. Next, we define our conversion tool class, which is a subclass of tk.tk. This means that our conversion tool is itself a Tkinter application window. In the init method, we start by calling the superclass's init method to initialize our Tkinter window. We then set the title of our window to Unit Conversion Tool. Then we create a dictionary called conversion_fns. This dictionary is going to map the types of conversions to their corresponding conversion functions, making it easy for us to call the correct function later on. Now let's look at these conversion functions. Each one takes the input unit, output unit, and value to convert. It then performs the conversion using the appropriate conversion formula. We'll start with the length_conversion method. This method takes three parameters, from _unit, to _unit, and value. The from _unit and to _unit parameters tell us which units the user is converting from into, and value is the actual number the user wants to convert. We first create a dictionary called length_dict where we map each unit of length to its equivalent value in meters. So, for example, 1 kilometer is equal to 1,000 meters, 1 centimeter is equal to 0.01 meters, and so on. Then, we use this dictionary to convert the value from the from _unit to meters, and then from meters to the to _unit. The value is then returned as the result. Next, let's take a look at the weight_conversion method. This method works in a very similar way to the length_conversion method. Here, we're converting weight units, so our dictionary, weight_dict, contains the equivalent values of each unit in kilograms. We use the same formula for conversion as before. The value, which is in the from _unit, is first converted to kilograms and then to the to _unit. The result is returned. Lastly, we have the temperature_conversion method. Temperature conversion is a bit different than length and weight because the formulas for converting between Celsius, Fahrenheit, and Kelvin are not linear. Therefore, instead of using a dictionary for the conversion rates, we have to use if-else statements to check the from _unit and to _unit and apply the correct formula. These three methods, length_conversion, weight_conversion, and temperature_conversion, handle all the unit conversions in our tool. They take the input value and units from the user, perform the necessary conversion, and return the converted value. By organizing these conversion formulas into separate methods, we make our code modular, organized, and easier to understand and maintain. Next, we define the calculate method. This method will be executed when the calculate button is clicked. It retrieves the current values from each entry field, converts them to float, and then performs the conversion using the appropriate conversion function. If the entry field is empty or contains an invalid number, it shows an error message. Moving on to the setup_UI method. This is where we create our user interface. We have a dictionary named options that contains our conversion categories, with each category having a list of its available units. We create a list called entries where we store references to all the UI components for each conversion type. We then loop over the options dictionary and create a label, two combo boxes for selecting units, an entry field for input, and another label for displaying the result. We also set the default values for the combo boxes to the first and second units in the list. And finally, we have a block of code under if name == mon. This is a Python idiom which means that the code block is executed only when the file is run directly, and not when it's imported as a module. Here, we simply create an instance of our conversion tool class and start the Tkinter event loop by calling main loop. And that's how our unit conversion tool works. It's a great example of how you can use Python and Tkinter to build practical applications. It not only showcases the versatility of Python but also gives you an introduction to working with graphical user interfaces in Python. Remember, the best way to learn is by doing. So, go ahead and play around with the code. Maybe you could add more conversion categories or even a feature to save conversions. Happy coding!